When automation works on your laptop but fails everywhere else, it often comes down to something boring and basic: packages. Packages are the add-on pieces of software your automation relies on, like building blocks that provide features you did not write yourself. In a beginner-friendly way, think of a package like a pre-built part you snap into your project so you can focus on the logic that makes your automation valuable. The catch is that those parts can change, disappear, or behave differently depending on where your automation runs. If your goal is deployable automation, the kind that runs the same way on a teammate's system, in a test environment, and in production, you have to treat packages as part of the automation itself, not as an afterthought. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A clean package choice starts with knowing what you actually need, because unnecessary packages create unnecessary risk. Every additional dependency is another moving piece that can introduce bugs, licensing constraints, performance overhead, and security vulnerabilities. Beginners sometimes grab a big package because it is popular, even if they only need one tiny feature, and that is like renting a moving truck to carry a backpack. A better mindset is to start from the problem and work backward, picking the simplest dependency that solves the real requirement. That simplicity matters because automation is often expected to run unattended, and unattended systems do not tolerate surprises. When your automation is part of a pipeline or scheduled job, a dependency that breaks becomes a broken operation, not just an inconvenience. Another early lesson is that packages come from somewhere, and where they come from affects how reliable your automation is. Some packages are maintained by large communities, have frequent updates, clear documentation, and predictable release habits. Others are personal projects that may be abandoned, renamed, or removed without much warning. Clean package selection means you look for signs of healthy maintenance, like recent releases, responsive issue tracking, and clear compatibility notes. It also means you prefer packages that do one thing well instead of packages that bundle unrelated features together. In automation, small, stable components are usually easier to trust than giant frameworks you only partly understand. The goal is not perfection, but reducing the odds that your automation becomes fragile because of someone else's choices. Once you choose packages, the next challenge is keeping track of exactly what you chose, because latest is not a stable plan. Packages evolve over time, and sometimes an update fixes problems, but sometimes it changes behavior or removes features your code depends on. If your automation installs whatever the newest version is at the moment it runs, then your automation is not actually defined, because its behavior can change without you changing your own code. Clean maintenance means you record the versions you expect, so you can reproduce the same environment later. This matters for troubleshooting, too, because if something breaks, you need to know whether it was your logic or a dependency change. Reproducibility is a core requirement for deployable automation, even when the automation itself seems simple. A practical way to think about dependency versions is to separate compatibility from certainty. Compatibility means a range of versions should work, while certainty means you know the exact version you tested. For automation that needs to be deployable, you often want certainty in the environments that matter most, like production and important test systems. You can still plan for compatibility by periodically testing new versions in a controlled way, but you do not want unexpected upgrades happening during a critical run. This is especially important when automation interacts with infrastructure, accounts, and permissions, because small behavior changes can produce large real-world effects. A minor change in how a library formats a request, handles a timeout, or validates input can cause downstream failures that are hard to diagnose. Clean package practices reduce that uncertainty by making dependency behavior predictable. It also helps to understand that packages are not only about features, they are also about trust. Every dependency you bring in becomes part of your automation's attack surface, because if it has a vulnerability, your automation might inherit that weakness. Automation often runs with high privileges, which means a dependency problem can have outsized impact. Clean maintenance includes monitoring for security issues, not in a panic-driven way, but as part of normal operations. The goal is to stay aware of updates that matter, especially security fixes, and to roll them in deliberately rather than accidentally. Beginners sometimes assume security concerns are only for big companies, but automation is exactly where small mistakes become big incidents, because it scales actions quickly and repeatedly. Treating dependencies as security relevant is part of keeping automation deployable and safe. Another common failure mode is depending on packages that require special system conditions you did not notice on your own machine. Some packages rely on specific operating system features, extra tools, or compiled components, and they might install fine on one platform but fail on another. Deployable automation usually needs to run in consistent environments, so you need to notice portability issues early. Clean package choice means you pay attention to how a dependency installs and what it assumes about the system. Even if you do not write installation steps in this course, the conceptual takeaway is that your automation should not secretly rely on the quirks of your personal setup. The more your dependencies demand special conditions, the harder it becomes to deploy the automation reliably. When you cannot avoid such dependencies, the clean approach is to document and standardize the required environment so it is not a hidden trap. Package management also includes the idea of grouping responsibilities, which is a fancy way of saying not everything needs to be deployed everywhere. Many projects have packages used only for development, like testing tools, formatting helpers, or build utilities, and those are different from packages required when the automation runs. If you mix them together without thinking, you can end up deploying unnecessary tools into runtime environments, which increases size, risk, and confusion. Clean maintenance means separating what is needed to run from what is needed to build and validate. This separation makes deployments smaller and more predictable, and it reduces the chance that a development-only tool causes runtime conflicts. For beginners, the key is to treat the runtime environment as a minimal, intentional space, not a dumping ground for every helpful thing you used while writing. A related concept is dependency conflicts, which happen when two packages want different versions of the same underlying component. This can look like random breakage, because the automation may behave differently depending on which dependency wins. Clean package maintenance tries to avoid conflicts by keeping the dependency set small, choosing packages with compatible ecosystems, and updating deliberately. If conflicts appear, the lesson is not that package management is hopeless, but that dependencies form a network and changes ripple through that network. Beginners often blame their own logic when something breaks, but it is just as likely that a dependency shift changed the network. The clean approach is to treat dependency state as something you can measure and control rather than a chaotic background detail. That control is what makes automation deployable, because you are not gambling on the environment. You also want to avoid the trap of copying package lists from random examples without understanding what they do. Tutorials often include extra packages for demonstration, or they target a different runtime environment than yours. If you blindly mirror those choices, you may inherit outdated dependencies, unnecessary complexity, or even risky components. Clean package choice means you treat examples as inspiration, not as a checklist, and you verify each dependency against your actual needs. This is especially important in automation because examples tend to assume interactive use, while deployable automation is frequently non-interactive and long-running. A package that is fine for a quick demo might behave poorly in a scheduled, unattended context, especially under load or in failure scenarios. The more you understand why a dependency exists, the easier it becomes to keep the automation stable as the project grows. Maintenance is not just about updating. It is also about knowing when not to update. Beginners sometimes hear, "keep everything up to date," and assume that means updating constantly, but deployable automation needs stability as much as it needs security. A clean practice is to adopt a rhythm where you evaluate changes, test them, and then roll them forward with a clear understanding of impact. That rhythm lets you incorporate important fixes without introducing random behavior changes during critical periods. When you update thoughtfully, you can also align updates with your release process so that dependency changes are visible and reviewable. The biggest risk comes from silent, uncontrolled changes, because those are the ones you discover only after the automation fails. Clean maintenance replaces silent change with planned change, which is a core difference between hobby scripts and operational automation. It is also worth understanding the difference between direct dependencies and transitive dependencies, because your automation may rely on packages you never explicitly chose. A direct dependency is one you intentionally added, while a transitive dependency is something that dependency pulls in behind the scenes. Transitive dependencies matter because they can introduce vulnerabilities, licensing issues, or breaking changes even when you did not change your direct choices. Clean package maintenance includes awareness that your dependency tree exists, even if you do not memorize it. The mindset is that you are responsible for the full behavior of what you deploy, not just the code you personally wrote. When something goes wrong, you want the ability to trace behavior back to a specific package and version, including transitive ones, so you can reproduce and fix the issue. A beginner-friendly way to tie this together is to think of deployability as repeatability under stress. When environments are calm, almost anything seems to work, but automation has to run when conditions are imperfect, like during outages, heavy load, or partial system failures. Clean package practices support repeatability by reducing surprise and narrowing the set of unknowns. When you know exactly what dependencies your automation uses, what versions they are, and why they are there, troubleshooting becomes a structured process instead of guesswork. This also supports teamwork, because your teammates can recreate the same environment and see the same behavior. In a distributed world, the environment is part of the shared project, even when the code is the most visible piece. That shared environment is what turns individual scripts into deployable automation. Finally, clean package choice and maintenance is a habit, not a one-time task, and it is one of the earliest habits that separates reliable automation from fragile automation. You do not need to be an expert to do this well, but you do need to be intentional. Choose dependencies for clear reasons, keep the set small, record versions for reproducibility, and treat updates as controlled changes. When you do that, your automation becomes easier to deploy, easier to test, and easier to trust, which is what matters when the automation is expected to run without supervision. Packages are not glamorous, but they are foundational, and foundational things need discipline. If you take package cleanliness seriously from the beginning, you reduce failure, reduce security risk, and build automation that behaves the same way wherever it runs, which is the real definition of deployable.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit BareMetalCyber.com.